Dear students, yesterday we have studied how to find the adjoint and inverse of a square matrix. Now let us do some more questions of this exercise 4.5 of determinants. This is the 12th question. Here A and B are two square matrices of order 2. We have to verify that AB inverse equal B inverse and A B inverse A inverse. Now, first of all, we have to find the determinant A. Determinant A will be equal to 3 multiplied by 5 minus 2 multiplied by 7, that is 1, which is not equal to 0. It means its inverse exists. And A inverse is adjoint A divided by determinant A. And for the square matrix of order 2, adjoint will be found by interchanging diagonal elements and by changing the sign of diagonal elements. So we get 5 minus 7 minus 2, 3. And determinant A is 1. So when you divide it by 1, it remains the same. So this is A inverse. Now we will find determinant B. Determinant B is 54 minus 7 multiplied by 8, that is 56, which is minus 2. Again it is non 0, so its inverse will also exist. And adjoint B will be change the diagonal elements and change the sign of off diagonal elements. So the adjoint B is 9 minus 8 minus 7, 6. And when you divide it by determinant B, which is minus 2, you get this as B inverse. Now AB, for the left hand side we require the product AB. AB is 3725 multiplied by 6879. Now multiply row by column and term wise and add them. 6 3s are 18 plus 7 7s are 49. ये आपका first term हो गया. Then for this element which is located at A12 location, you have to use first row and second column, multiply them element wise and then add them. We get 24 plus 63. Similarly here the remaining terms. So this is the product AB. Now to find AB inverse, we require determinant AB. So determinant AB is 67 multiplied by 61 minus 87 multiplied by 47, that is minus 2. Again it is not 0, so its inverse will also exist. Now to find the inverse of AB, we use the formula adjoint AB divided by determinant AB. So it is 1 by minus 2 into square matrix 61 minus 87 minus 47, 67. Now the right hand side we require B inverse A inverse, so we multiply them and it becomes minus half. Then multiply again row by columns and add them. तो फर्स्ट रो फर्स्ट कॉलम का एलिमेंट वाइज प्रोडक्ट करके ऐड करेंगे. देन यू गेट 45 प्लस 16. इसी तरह से A12 लोकेशन को फाइंड आउट करना है, तो फर्स्ट रो सेकंड कॉलम. A21 लोकेशन को फाइंड आउट करना है, तो सेकंड रो और फर्स्ट कॉलम के एलिमेंट्स को कंपोनेंट वाइज मल्टीप्लाई करेंगे. देन इट बिकम्स minus 35 minus 12, that is minus 47. फिर आपको लास्ट एलिमेंट फाइंड आउट करना है A22 लोकेशन पर, तो आप सेकेंड रो सेकेंड कॉलम को यूज करेंगे. तो 7 7 49 प्लस 18 67 आ जाएगा. So from the first equation and second equation, you observe that AB inverse is equal to B inverse A inverse. Now the next question is, if A matrix is 3, 1, minus 1, 2, show that A square minus 5A plus 7I equal to null matrix. O means null matrix, and hence find A inverse. So hence find A inverse kya hai? It means you have to use this relationship to find the A inverse. You have not to use A inverse is equal to adjoint A divided by determinant A. इससे नहीं निकालना है, हमें इस रिलेशनशिप को यूज करके A इनवर्स को फाइंड आउट करना है. तो इस रिलेशनशिप में हमें A स्क्वायर की जरूरत है, तो हम पहले A स्क्वायर फाइंड आउट करेंगे. Then A square is A multiplied by A, so multiply them, first row, first column, then 9 minus 1 is the first element. At the second element, which is located at A12, use first row, second column. So 3 multiplied by 1 plus 1 multiplied by 2, that is 3 plus 2, 5. Similarly, the lower ones, minus 5, 3. Now put the values of A square and A and I in the left hand side of the given expression. Here you have to take I means identity matrix. Now since A matrix is a square matrix of order 2, I will also be of order 2. So put the values of all the terms, we get this expression. Now multiply 5 with each element of the second matrix, and similarly 7 with the identity matrix. So you get this expression, and to add or subtract the two matrices, we have to add them component element wise. So the first term will be 8 minus 15 plus 7. You can directly use, or so you get 0, and again 5 minus 5 plus 0, it is also 0, minus 5 plus 5 plus 0, it is also 0, then 3 minus 10 plus 7, so it becomes 0. So you get the null matrix, which is to be proved. Now how to find A inverse using this? For that, you multiply this equation by A inverse, all the terms by A inverse. So you get A square A inverse minus 5A A inverse plus 7I2 A inverse is equal to O A inverse. Now A into A inverse is identity matrix, so we can write it as A, because it becomes A into A inverse, and this A inverse is identity matrix, and identity matrix again multiplied with A gives you A. So the first term becomes A. Second term becomes minus 5. A inverse will be replaced by I. Here I have written I2 because we have to take the identity matrix of order 2. And I2 multiplied by A inverse is also A inverse. So we have replaced it by A inverse. And on the right hand side, when null matrix multiplied by any matrix gives you again the null matrix. So from here you can find 7A inverse is equal to minus A plus 5I2. So put the values of A and I2 here, you get minus 3, 1, minus 1, 2. This is A matrix, and 2 means identity matrix. And then simplify it. 5 is to be multiplied with each element of the identity matrix first. So it becomes 5, 0, 0, 5. And then you have to add the two matrices term wise. First A11 minus 3 or plus 5, Similarly, minus 1 plus 0, 1 plus 0, and minus 2 plus 5. So you get 2 minus 1, 1, 3. So from this you can find A inverse as 1 by 7 of this matrix. That's all for today. Thank you.